Year 12 PPE question 11 about a couple of circles. So we start with circle C1 with that equation. I've already sketched it here so we know what it looks like, but let's work on this. And we're looking for the line L that is a tangent to the circle at the point -5, 7. Well, we can see where that point is, and if we just sketch it in, it's about there. So the line we're interested in will go through and cut there and then continue off over here somewhere. Okay, so that's going through that point there, okay, which is -5, 7. And what we're going to do is we've got to first of all work out the center of the circle, okay, and the center is here. And we've got to look at the equation or the gradient of the radius, because that will be the negative reciprocal of the gradient of the tangent. So that's the problem that we're sort of looking to solve. Let me try and put that in the right place. So it was coming from the center here to roughly to there. Right, okay. Now let's do this algebraically. So if we write the equation of the circle in the form of completed square form, so we've got x plus 9 all squared, okay, take away 81, okay, that's the residue when you do the completed square of that, or the perfect square of that. Then you've got to do the y1, which is going to be y minus 1 all squared with a residue of 1, okay, and all of that has to equal well, it's plus 30 equals 0, okay. Now if we just move everything across, we get x plus 9 squared plus y minus 1 squared, okay, and that equals 52. So it's giving us the center of the circle, which we can see is the point -9, 1, and it's giving us the radius, which is clearly going to be root 52. Okay, now to find the equation of L to the line L, which is this one here, okay, that's what we need, the equation of that line, the gradient of L, okay, so the gradient of the radius, okay, the gradient of the radius, let's do that first. So the gradient of R is going to be the change in y divided by the change in x, okay, and it's going to be well, it's going to be 7 minus 1 over it's going to be -5 minus -9, -5 plus 9, okay, and that is 6 over 4 or 3 over 2, okay. And if that's true, then the gradient of the line L, the gradient of L, is going to be -2/3. And the equation of L, therefore, is going to be, let's just write it down here. So L has equation, okay, y minus y1, so y minus 7 equals -2/3 brackets x minus -5 or x plus 5, okay. If you process that, multiply everything by 3, okay, we get 3y minus 21 equals -2x plus minus 10. And finally, if you just reorder that, you get 2x, okay, plus 3y minus 11 equals 0. Okay, and that answers the first part of the question, which is to find an equation for the line L. Okay, and that's in the form ax plus by plus c equals 0, which is what they normally ask for. Now we have a different circle, C2, which has that equation given in the question here. Let me just partition this off, and we can work on this over here. Okay, so let's move on to C2, and the same sort of process to start with. We have x minus 4 squared, so I'll just put this here, part 2. Okay, so we have x minus 4 all squared. Okay, by completing the square with the leftovers of 16. Okay, and we then have y plus 6 squared, okay, minus 36 plus this value k equals 0. Okay, now what we've got to do is, given that the circle sits entirely in the fourth quadrant, okay, that means it can't overlap into across any of the axes, basically. And we know where the center is from this. Let's just finish this off first, and then I'll pull in a graph of this circle. So we've got y minus 4 squared plus y plus 6 squared. Okay, so the center of this circle is at the point 4 comma negative 6. Okay, and that equals 52 minus k. Okay, now what we've got to do is consider the range of possible values of the radius to cause the circle to stay in the bottom right quadrant like this. Okay, so you can see I've got the axes there. If I just leave that up there for the moment. Okay, now I've just done a random value of k that's showing the circle with its center at the correct point, but currently inside the quadrant as it's required to be. So there's the center of the circle at 4 comma negative 6. All right, now obviously as the radius gets bigger, it's going to cross the y-axis first when the radius exceeds 4. So the radius has to be less than 4, but it also has to be greater than 0. Okay, well, the radius is given by the square root of 52 minus k. So 52 minus k has to be less than 16. Okay, so 52 minus k has to be less than 16. Okay, let's do that one first. And therefore, if you add k to both sides, 52 and take away 16, 52 minus 16 has to be less than k. Okay, and that means therefore that k has to be greater than 36. Okay, so k has to be greater than 36. Okay, now we also have to consider the minimum radius, which of course is 0. Okay, so 52 minus k has to be, let's just do that over here, 52 minus k has to be greater than 0. Okay, which means that k has to be less than 52. Okay, well, that's simple enough. We can put that into a single inequality and answer the question, and that is that 36 is less than k. Okay, and that in turn has to be less than 52. Okay, and anywhere within that range will give a circle with that center that stays in the fourth quadrant. Okay, and just to remind you, the quadrants are labelled anti-clockwise. So as you come round the axis, the first quadrant is here, the second one's here, the third is here, and the fourth one is in the bottom right hand part of the axis. Okay, I hope that was helpful.